All right, so we're on page 115 of your workbook. And what we're looking at in this third lesson of chapter 5 are linear function patterns. So we're going to be looking at patterns that the numbers follow as they go through an XY table, graphing them, writing equations from them. Most of it should just be a review of things that we've done in the past. So let's look at activity 1. First thing it says is plot the points from the table in a coordinate plane. So remember, whenever you plot points, it always goes X and then Y. You go over and then up. So for this first ordered pair, we have 0, 150. So over 0 up to 150. Then 2, 125. So over 2 up to 125. 4, 100. 6, 75. And 8, 50. Then it says to write a linear equation for the function. So remember, with our equations, we want them to be y equals mx plus b. So remember, b is your y-intercept. Where does this cross the y-axis? And if I look, I notice that it crosses at 150. And then the m is your slope. Okay? So if you notice, if you look at your graph, it's actually, each line is going by 25s. So we're actually going down 25, so that makes that a negative 25. And we're going right 2, because those down there go by 2s. So your slope for this one is negative 25 over 2. Your y-intercept is 150. So if we take that and we put that into an equation form, we have y equals negative 25 halves x plus 150. And that's your equation for part A. All right, if we look at part B, again, we need to graph these first. So the point 4, 15. So I'll go over 4, up 15. 620. Over 6, up 20. Okay, so I've noticed as I've started graphing that along the x-axis they're actually going by 2s, and on the y-axis they're actually going by 5s. So just make sure you know that as you start plotting. Then we have 825, 1030, and 1235. So again, we want to write an equation for this. Okay, now my slope for this one, okay, if I start here, I know I'm at 15, so I would actually go up 5 and right, remember one box is actually 2, so I'd go right 2. So my slope is 5 over 2. Now as I look at the graph the way it is right now, it doesn't cross the y-axis, but what you're going to look for is where would it cross the y-axis. So if you continue this pattern, there would be a point right here, and then there would be a point right here, and that's where it's going to cross the y-axis right here, and that is at 5. So your y-intercept is 5. So whenever you write your equation, y equals 5 halves x plus 5. Okay, moving down to part C. Again, we need to plot these points on the graph. So we have negative 4, 4. So we go left to negative 4 and up 4. So I'm noticing that as I went over, they're going by 1s. But as I go up, they're actually going by 2s. So keep that in mind and be careful when you plot these. Then we have negative 2, 6, 0, 8, 2, 10, and 4, 12. Okay, so my slope, let's see, if I just start right here, I know I would have to rise. I'm actually rising 2, and I'm running 2, so my slope is actually 1. And then it crosses the y-axis right here at 8, so my equation for this one would be y equals, it would be 1x, but remember you don't need the 1. So just x plus 8. All right, and then finally part D. As I start to graph, we have -4, 1. So I notice on my graph these are all going by 1s. I have -2, 0, 0, -1, 2, -2, and 4, -3. Okay, my slope here, let's say if I start right here in the middle, I recognize that I go down 1, so that's -1, and then I go right 2. So -1/2 is my slope, and my y-intercept crosses right here at -1. So your equation for this, y equals -1/2 x minus 1. So again, those 4 should have just been a review. That's something that we did a couple of chapters ago. Graphing, plotting the points, and then just being able to write the equation of the line that's there. Now, moving to page 116. Okay, here we're going to write a function, but then what do the variables x and y represent? And they've given us pictures to kind of help gauge that, and then we need to graph it. Okay, so part A, I look at my x's and I see 1, 2, 3, 4, and 5. Those are my inputs, those are my domains. And then if you notice on your y, they've thrown in some pi's in there. 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. This one is a really easy pattern to pick out. When you're looking for patterns, you're trying to figure out, how do I get from x to y? How do I get from x to y? So you could go ahead and graph these if that would make it easier for you to see. So I notice my x's go by 1s, so I'm actually going to go every, let's see, 1, 2, 3, I can go every other 1. So it would look like that. And then my y's, I'm going to kind of do the same thing, go every other 2 pi, 4 pi, 6 pi, 8 pi, and 10 pi. And then when I graph, 1, 2 pi, 2, 4 pi, 3, 6 pi, 4, 8 pi, and 5, 10 pi. So there's my graph. Now, as for my equation, okay, I notice whenever I go to do my slope, let's say I start at this point, I'm actually rising 2 pi. You have to keep the pi in there because it is technically a number. And then whenever I run, notice I'm only actually running 1. I'm running from 1 to 2, so that's only 1 space. So my slope is 2 pi over 1, or just 2 pi. Okay? And then my y-intercept, now the points that I have don't cross the y-axis, but if I were to continue them, I would have a point right here at the origin. So my y-intercept is actually 0. So for my equation, y equals, my slope was 2 pi, so that goes in front of the x. And then y-intercept is 0, so we don't really need anything there. Okay, so here's your equation, y equals 2 pi x. Now that one's a little weird because it has the pi thrown in there, but it's the same process as if the pi wasn't there. So if you need to pretend that the pi is not there to help it make more sense, you can do that as well. Okay, part B. Okay, we can go ahead and graph these. So I'm going to do the same spacing on the graph as I did on the last one. Now, notice that your y values actually start at 10 and then go by 2s from there. You need to be consistent along your entire y-axis. So just because these go by 2s, that doesn't mean you can start with 10 right here and then go by 2s. You need to keep it consistent all the way through. So I'm going to go ahead and make every single little mark 2. That way I have enough room to cover everything. And then I'm going to graph. So 1 was at 10, 2 was at 12, 3 was at 14, 4 was at 16, and 5 was at 18. Okay, so if I pick out my slope, notice I'm actually rising 2, and I'm running really only 1. You've really got to pay attention to what the increments go by on your graph whenever you're doing the slope, because it's very, very easy to mix those up. So my slope is 2. My y-intercept, again, it doesn't cross the y-axis, but if I continue this pattern, I'm going to have a point right here at 8. So my y-intercept is 8. So my equation, y equals 2x plus 8. Okay? Now, we are actually going to skip down right here. This is on page 118. It says 5.3 practice at the top. Okay, and I actually want you to work on this as your assignment for today. Okay, they're very similar to the ones that we just did for the graphs. All you're doing is writing, it says write a linear function. All that means is write the equation that fits the scenario. Okay, fits the graph or fits the table. For 3 and 4, you might want to draw a graph, or just go ahead and plot them on these up here if you want, if that would help you write the equation. Then number 5, again, these are the points that you're going to plot on your graph, so you're going to have to watch your spacing, okay, because numbers get pretty high. All right. Is the domain discrete or continuous? That's what we talked about yesterday, so you may need to look back at your notes for that one to figure out whether it's discrete or continuous if you don't remember. B, write a linear function for this, so again, just write the equation. And then C, just answer the question, what is the distance traveled after 3 hours? Okay, 3 is not listed in your table, but that's what you need to figure out is at 3 hours, how far would you have driven? Okay, so this is going to be your assignment for section 3 of this chapter.